So in our class of DT-based video lecture, we will discuss on tree energy. Let's recall the previous one. What is data structure? What is data structure? Anyone? What is data structure? Data structure is a concept of organizing or storing the data in the computer so that we can retrieve and access it efficiently. Yes or no? So, for storing and for accessing, we are using the data structure concept. So, there are two types of data structures, linear data structure and non-linear data structure. In linear data structure, we have learned arrays, stack, queue, linked list. And today, the tree ADT falls under the non-linear data structure. Tree and graphs are non-linear data structure which are not continuous in its storage. Yes, in memory. Okay. Next slide. So today's topics for discussion are why we go for the tree concept and tree ADT fundamentals and tree terminologies and why tree traversals in the real world. With the real world applications, we are going to see the tree concept. So, inspired by the tree in the nature, the scientists have developed this concept by reversing it upside down, making the root at the top. Yes. So, the scientists, though they are persons, though they are scientists, somehow they have to be inspired by the biological nature. Those are called biological inspired algorithms. Yes, that is there in computer science terminology. Biological inspired algorithms or algorithms which are inspired by the nature that are there. So, in the nature, we are seeing tree that you have to reverse it back for the root to come to the top, and we have hierarchy structure. So, tree is a hierarchical way of storing data level by level. Yes? Okay. Next slide. That is what. So, design thinking is empathize. Please empathize. Why trees matter in our digital world? Why trees matter in our digital world? Why this tree concept? Why this tree concept is, in file systems, imagine you students, folderless hierarchy in computers. You know, we store folders. Yes or no? In computer, we store data in folders. Yes, folders are stored in tree concept, in hierarchical levels that you might have learned in your classes. So, you have folders which are in the level by level structure. So, in order to store those things, we need a tree concept and we have to learn theories and many other algorithms under that. So, that is a necessity for a tree concept. And then, imagine a DBMS. In DBMS, we want to store the employees of a company, starting from the CEO to the non-staff. So, we have hierarchical levels, we have payments to give them, we have starting of their joining to the same. So, we have hierarchical levels. So, in an organization, we need a tree structure. So, it is a tree structure. The data stored is in the tree structure. So, this concept tree concept, tree algorithms, when we use, we can store the organization, employee details. Yes, and then coming to the programming. The data object model in HTML. You see the HTML language, we have tags, closing and opening and closing tags. Yes or no? Yes? Yes. So, that will be in the tree comment. So, for that also, we need tree concept in order to store it. So, we have these many applications in real world. There is a necessity. So, we need a tree concept in order to store and retrieve efficient. Next slide. So, tree editing. Editing means abstract data type. Abstract means what? Hiding the values that are not relevant to the user. So, it will show you the details that are only essential. If you open the database, it is only showing the details in the table in a user-friendly manner. Only the relevant one. It's not actually showing you the pre-format but how it is stored. Yes or no? So, the tree is a hierarchical structure, data structure with finite number of nodes. And it is connected by edges. That is important. It is connected by edges. Without no cycles. No loops are found. And we have collection of data. That is the node. The node, it is actually the data. The node represents data. And then parent child. We have relationship. This is the parent mix. This is the child. And hierarchical structure recursively, you have hierarchies. Recursively, you have hierarchies. Levels. Yes. And then it is a two-dimensional data structure. Tree is a two-dimensional data structure. Next slide. Let's discuss few terminologies that are important. That may be asked in 2 marks. You see, tree data structure. So this is what everybody, what is this? Hands and mouth. Root node. Also called key. And then here, this is the parent for this children. Yes or no? Yes or no? And this is the parent for this children. And if you take this thing, this is the factory. Yes or no? This is factory. And if you take this thing, this is a factory. Each one of this particular, this thing is a factory. One parent and then it's a binary search tree. So one parent with 2 child is a factory. Here, like that it goes. Binary search tree, each parent contains only 2 children. That is what binary. And then siblings. Siblings means what? Nodes of the same parent. Yes or no? So 2 siblings will be there because it is binary. So parent, children, siblings. These two are siblings. And then child. This is the binary, this is the child. And then coming to the leaf node. This is so important. Which node does not have any child node is called leaf node. So, is this having any other child node? No. So, any of these nodes is not containing any child node. Okay? So, this is called leaf node. Yes, leaf node does not contain any other child node. That may be the last node of the tree. Yes. So here is an activity. Can you map your family members to these rows? Who is the root? And is a parent-child relationship, find the siblings from the lead nodes. So please try that. And then, thank you, class. Thank you.